Dear friends, welcome to my channel. Today we are going to see how to use POM-QM software for graphical method in operations research. So as you can see, we are starting the POM-QM software. This is the opening screen of the POM-QM software. These are all the tools available and here are the side things. So first, let us see our problem. So first one is linear programming graphical method. Hi, I am Anand J. Kumar A. So the first problem statement is the ABC company has been a producer of picture tubes for television sets and certain printed circuits for radios. The company has just expanded into full-scale production and marketing of AM and AM/FM radios. It has built a new plant that can operate 48 hours per week. Production of an AM radio in the new plant will require 2 hours and production of an AM/FM radio will require 3 hours. Each AM radio will contribute rupees 40 to profit while an AM/FM radio will contribute rupees 80 to profits. The marketing department, after extensive research, has determined that a maximum of 15 AM radios and 10 AM/FM radios can be sold each week. Formulate a linear programming model to determine the optimum production mix of AM and FM radios that will maximize profit. Solve this problem using the graphical method. I hope you are aware about how to solve using graphical method. Now we are going to see how we can use the POM-QM software to solve the problem. So this is the equation and this is the solution. Now let us see how to generate in POM-QM software. First we are going to select the graphical method. So we're going to choose integer linear, let us see, linear programming. So let us give the title graphical method example 1. So we have an objective function over here and we have 3 constraints over here. The last constraint we are not taking into consideration. So number of constraints is 3. Next is number of variables. Here we have only x1 and x2, so it is 2 variables. So therefore number of variables 2. Next our objective is to maximize. So we have choose maximize. Row name we are giving as constraint 1, constraint 2, constraint 3. Column name we are giving x1, x2, x3 and then we click OK. So here is the format over here. So what we are going to do, we are going to maximize 40x1, 80x2. So here we enter 40 and here we enter 80. So here you can see the equation is getting built up. Next the constraints. 2x1 plus 3x2 less than or equal to 48. 2x1 plus 3x2 less than or equal to 48. Here we can drop it down to equal to or greater than. Next is x1 less than or equal to 15. 1x1 less than or equal to 15. Next is x2 is less than or equal to 10. 1 x2 is less than or equal to 10. Now we have formulated all the problem statement. Our next job is to solve it. So here we are going to click on solve. We have solved it. So in solutions, we are going to see the graph. So this is the answer. So this particular point with x1 is equal to 15, x2 is equal to 10. So finally this particular point is the solution with the x1 is equal to 9 and x2 is equal to 10, and our maximum profit is 1160. So this is the answer. Let us go to the next problem. Next problem is a diet for a 6-person must contain at least 4000 units of vitamins, 50 units of minerals, and 1400 calories. Two foods A and B are available at a cost of rupees 4 and 3 respectively. If one of A contains 200 units of vitamins, 1 unit of mineral and 40 units of 40 calories, and 1 unit of food B contains 100 units of vitamins, 2 units of minerals and 40 calories. Formulate this problem as a linear programming model and solve it by graphical method to find combination of foods to be used to have least cost. So this is a problem. If we formulate it, this is the equation that we'll get. Now we are going to solve it using POM-QM software. We're going to give it as new. We are going to name it as graphical method example 2. So again in this problem, let us see, we are having two variables and three constraints. Let us see, two variables and three constraints. So here we enter 3 in the constraint and 2 in the variables. Our objective is to minimize it. So we are selecting minimize option. Row names are constraint 1, constraint 2 and constraint 3. Column names are x1, x2, x3, and we are going to give it as OK. Now it is minimize 4x1 plus 3x2. Minimize 4x1 plus 3x2. So what is our constraint 1? It is 200x1 plus 100x2 greater than or equal to 4000. 200x1 plus 100x2 is greater than or equal to 4000. Second constraint is 1x1 plus 2x2 greater than or equal to 50. 1x1 plus 2x2 is greater than or equal to 50. Our third constraint is 40x1 plus 40x2 greater than or equal to 1400. 40x1 plus 40x2 is greater than or equal to 1400. Now let us solve it. So click on the solve over here. So we are going to choose the graph. So this particular point is our solution, which corresponds to So there are many solutions over here for this particular problem. So the best one is 5x1 plus 30x2 gives 110. Let us see. So these are the points over here. So this is a minimization kind of problem. So this is the minimum value which we are getting. Our next problem statement is a firm plans to purchase at least 200 quintals of scrap containing high quality metal X and low quality metal Y. It decides that the scrap to be purchased must contain at least 100 quintals of metal X and not more than 35 quintals of metal Y. The firm can purchase the scrap from two suppliers A and B in unlimited quantities. The percentage of X and Y metals in terms of weight in the scrap supplied by A and B is given below. Metal X from supplier A 25%, supplier B 75%. Metal Y supplier A 10%, supplier B 20%. The price of A scrap is rupees 200 per quintal and that of B is 400 per quintal. The firm wants to determine the quantities that it should buy from the two suppliers so that total cost is minimized. So the formulation of the problem, let us see. So it's a minimization type of problem. So we are having three constraints and two variables. So now let us take the software, new, graphical method example 3, constraints are 3 and the variables is 2. This is a minimization kind of problem. Row names are constraint 1, constraint 2 and constraint 3. Column names are x1, x2, x3 and we are giving OK. So let us enter the values 200 x1 plus 400 x2. 200 x1 plus 400 x2. x1 plus x2 greater than or equal to 200. 1x1 plus 1x2 is greater than or equal to 200. Next is x1 plus 3x2 greater than or equal to 400. 1x1 plus 3x2 greater than or equal to 400. Next is x1 plus 2x2 less than or equal to 350. 1x1 plus 2x2. Here we are going to change the symbol to less than or equal to 350. Now let us find the solution by clicking on the solve over here. We are going for the graph. So this particular point is the solution corresponding to 100x1 plus 100x2. It gives around 60,000 Z value. So here you can see the solution over here. So friends, I hope you have understood how to use the POM-QM software for doing the graphical method. Thank you for watching the channel.